this video, we're going to temporarily depart from my ongoing pinball restoration series, and we're going to do a little desk repair. So in this box, I have 2 parts oscilloscopes that I'm going to repair and bring back to life. So if you found me through my pinball videos, I also repair more standardized electronics like test equipment, computers, and game consoles, and I think that's pretty interesting as well. So if you follow me for my pinball content, I hope you'll stick around for these kind of videos as well. So let's go ahead and open this box up and see what we have here. All right, let's go ahead and get this opened up. So what we have in here are 2 digital oscilloscopes from the late 90s. They're both Tektronix scopes. One of them is a 60 megahertz scope and the other is a 100 megahertz. Let's see what they look like. It looks like it's pretty well packed. That's good. Yeah, it looks like these were packed pretty well. I can see there's a piece of styrofoam that is keeping the 2 front ends from hitting each other, so I'm glad to see that. Well, all that cardboard certainly made a mess of things, but here are the 2 scopes. We have a Tektronix TDS220 and a TDS210. This is the 60 megahertz one, and this is the 100 megahertz one. And the eBay seller was very descriptive about all of the problems that these scopes had, and they're not very bad, it seems like. The 220 is the better one of the 2. You can see it's missing some knobs, but I have a 3D printer, so I can 3D print the missing knobs and have those functional again. This scope, it has a loose BNC jack on the first channel, so it's not able to properly measure a signal because of that. So I'll have to take this scope apart and see if it just broke off of the solder pads or the solder pads themselves are broken. We will see. The channel 2 connector is okay, and the external trigger jack is okay. Looks like it's in very good condition. It just needs a little bit of a cleaning. The power button is still here, is not there on the TDS210, but I can 3D print a new one of those. It has its handle, which is still intact. The other one does not have its handle, which is okay. And on the back, you can see we have a little blanking plate here. On these scopes, you could install an expansion module that would allow you to print out what is being displayed on the scope through serial, parallel, or GPIB, but that is not installed on either of these scopes. It is nice to see that we have a little flip out foot so that when you have the scope sitting on your desk, it doesn't have to be perfectly straight like that. You can flip open the foot and now it's propped up a little bit. It makes it easier to see what's on the screen. The TDS210 is in similar condition. It has its little flip down foot on the bottom still, so that's nice to see. A couple missing knobs on it as well. This one's got a slightly different problem. The channel 2 jack is completely destroyed, so I'm going to have to replace that. The channel 1 jack is nice and tight, and the external trigger jack is nice and tight. So not serious problems with either of them. This scope is exactly the same as the 220. It's just the lower end version, so it can only measure up to 60 megahertz as opposed to 100, but everything else is exactly the same. You can see this one on the top is missing its little power button that sticks out, but I have found a STL file that I can 3D print for that, so that'll be a very simple problem to fix. And this scope is also missing its handle, so someone probably had it apart and broke the handle, but that's not a big deal because this scope is very light, so not a huge issue that that is missing. And this one has the same thing, it just has the blinking plate. There is no expansion module in it. Although this one does have some interesting labels in the back. Let's take a look. This scope was obviously refurbished at some point in its life. You can see we have a label, reconditioned equipment, Tektronix. So obviously this scope was sent back to Tektronix and had some issues fixed. There's another official Tektronix label that says PS mod. That probably means power supply mod, because what I read about these scopes is that when they were first released, they had a grounding problem, and there was a little modification that Tektronix made to fix that grounding problem, and so that scope obviously has had that done. The 220 just has its standard label on the back, so either it didn't receive the mod or it was not marked that it was modded But we'll take both of these scopes apart so we can fix their problems and see how they look on the inside. But what I want to do right now is power each one of them up and see how well they function as they are. All right, so let's first look at the TDS210. This one does not have the power button, so I'm going to have to stick something down there in order to turn it on. It's plugged in and nothing happens, so let's go ahead and push power and see what it does. Stick this in here and push the button. There it is. Tektronix TDS210 digital real-time oscilloscope. All the tests passed, so it started up normally. Now the screens in these oscilloscopes are monochrome and they run off of a CCFL backlight which can dim over time. So it may be a little bit dimmer than you would expect. It's perfectly readable to my eyes, but in the service manual for these scopes, Tektronix does say that the backlight is a user replaceable part. So maybe sometime in the future I could replace the backlight with a new one and get more brightness out of these screens. But as you can see, the scope did come up and it is looking for a signal. Let's go ahead and test if the division adjustments work, and it looks like they do. You can see our time base adjustment is working. Our trigger level is adjusting. I went ahead and bought some new probes for these scopes so we can go ahead and test and see if it's actually able to measure a signal. So what I'm going to do to briefly test out these scopes is I'm going to hook up a probe to the working BNC jack. This one, got some noise there. This one being the first channel. And the reason we're getting this noise is because we have the voltage per division at a very low level. We have it at 200 millivolts per division. So if I change this to something like 5 volts, it's not going to show anything. I'll set it for 2 volts per division so I can show you what I'm about to do. So on virtually every scope, there will be something called probe compensation. It'll give you a ground and a 5 volt DC hookup right here. And that is so you can calibrate your probes. So what we're gonna do is we're gonna hook the ground up to the bottom connector and then the probe itself to the 5 volt. And what we should see is a 5 volt square wave going across the scope. And you can see we do. I'm going to go ahead and push the auto set button so it will trigger on it correctly. And there we go. And it looks like maybe the scope isn't configured correctly because you can see we have channel 1 at 200 millivolts per division, but that is not 500 millivolts, that's 5 volts. So what I think we need to do is go into it's the channel 1 menu. So what we need to do is the probe is currently set to the 10x position, but the scope is set to 1x. So I need to change this to 10x. And now you can see we have our voltage per division correct. It's 2 volts per division. And so now if you count the divisions, the middle is 0, 2, 4, and it goes up halfway to 5 volts. So it looks like our probe compensation is working. But in order to calibrate the probes, what you need to do is there's a little adjustment on the probe. If I go ahead and turn it, you can see we have a little hole right there. There's a potentiometer in there, and you're supposed to adjust that until you get a nice flat square wave. So if I go ahead and increase my time base, you can get a better view of that. It's pretty good right now, but I'll go ahead and put an adjuster in there and show you what that looks like when you're adjusting it. So here's a little adjuster. So if I go ahead and stick that in there and turn the pot, you can see I just turned it a little bit and now it's no longer flat. So if you see something like that, you want to rotate this until it is perfectly flat. And you can see if I turn it too far, it goes down like that. So we'll turn this right there. That is perfectly flat. That looks really good. So now the probe is calibrated, so when you're measuring a signal, you're going to get accurate data of what you're actually seeing. So now that that probe is calibrated, I'm going to go ahead and put the other one in because I bought a set of 2, and we'll calibrate that one. It looks like this scope may also have a loose BNC jack on channel 1 because if I move it a little bit, you can see that noise goes away. But if I let go and move it around again, you can see we have some noise. So I think I'm going to have to solve that problem on this scope as well. All right, we'll go ahead and auto set. Yeah, that one's a little bit worse in the calibration. You can see we have some curves on the edges of that square wave. Too far. Perfect, right there. So both probes are calibrated. So this scope actually does work. We just need to fix the second channel input and maybe the first one. And then we'll print some knobs, print a new power button cover, clean it up, and the scope should be perfectly fine. Yeah, I think the first channel's got a little bit of issues because if I hold it like that, it's okay, but if I let go, we got a whole bunch of noise. So we'll definitely be looking at that. What I want to do though is I want to see if the scope can measure DC voltage correctly, because at one point I had a cheap scope off of Amazon that couldn't do that. So I'm going to hook it up to my bench power supply. I'm going to set it to 5 volts. Ooh, go ahead and manipulate this. Okay, so we definitely have problems with that first channel, but you can see it is measuring the voltage correctly because we are at the 5 volt mark on the scope. I'm going to go ahead and adjust it down to 4 just so it lands on a division. Yep, that measures perfectly fine. So once I figure out the problem with that first channel, this scope should be very reliable again. So now we'll go ahead and we'll take a look at the other scope. All right, here's the 220. Let's go ahead and push the power button and see what it does. Came up. TDS220, all the tests pass. So I can see some adjustments we have to make. The probe is set to 100x. We'll go ahead and set that to 10. And I can see we have some vertical cursors turned on. I think those are just used for kind of getting an idea of what you're measuring, like you can make marks at certain points. So if I go into the cursor menu, I think I can turn them off. Yep, there we go. So now we just have the waveforms on the scope. Looks like channel 2 is on. Let's turn channel 2 off. There we go. And channel 1, I will bring that back down. I have to turn one of the missing knobs down to 0. So it can rest right in the middle there. Let's go ahead and set our voltage per division up to 2 volts. Do it on both channels. This display is brighter and more cool white than the other scope, so I think the backlight in this one is a little bit healthier. But let's go ahead and hook up a probe and we will just see if some basic functions work. So this one, we already know that the channel 1 jack is loose. I'm going to go ahead and just hook it up to that just to see how bad it is. Yeah, we definitely have some noise. Yeah, this one's pretty loose. Yeah. That one right now is not usable. So let's go ahead and put it to channel 2. Go ahead and disable channel 1 and turn on channel 2. Okay, this jack seems to be pretty reliable because if I move it around, we have no noise. So that looks like it's working fine. We'll go ahead and attach the probe to the probe compensation jack on the front and see if we have our nice square wave. Looks like we do. Let's go ahead and auto set just to set the trigger correctly. There we go. Our voltage per division got a little messed up doing that. We'll move this up to right there just so we can see that it's working. Okay, channel 2 is also set to 1x. Let's change that to 10. So now our voltage per division is correct. You can see we have 2, 4, and we're at the 5 volt mark. So like we did on the other one, let's go ahead and hook it up to my bench power supply. I shouldn't expect to see as much noise or any noise when I hook up the ground terminal. I'm going to do that right now. Okay, no noise. My power supply is set to 5 volts. Let's go ahead and hook up the probe to it and see if we get 5 volts. And that we do. Look at that, nice and stable. Go ahead and decrease it down to 4 just to make it land on a division. You can see it is measuring that perfectly well. So besides some flaky B and C jacks, these scopes seem to be working perfectly fine. So what we'll go ahead and do now is we will pop back covers off on these scopes. We'll take a look at the inside, take a look at those B and C jacks to see what's going on, and we will go from there. All right, so first let's look at the TDS210. So normally to take apart these scopes, you'd have to remove the power button and the handle, but since they're both missing on the scope, I don't have to do that. The power button would just come out. If you grabbed it with a pair of tweezers, it would just pull right off with a little bit of force. And the handle you would just stick a plastic spudger in here and kind of pry it out, get one of the sides out, and then do the same on the other side. But we don't have to do that here. But we do have to remove the blanking plate. So to do that, there's a little latch up here on the top that you can press with a plastic spudger. It's kind of hard to get your finger in there. But once you press it, you can pull up on the blanking plate like that. I don't think that's ever come out before. That took a lot of force. And then you just lift out from the top, and then that blanking plate comes out. You can see there's nothing in there. So your expansion module would go right there. And if the scope did have a handle, once you removed it, that gives you access to 2 T15 screws right under the handle. So we have to remove those. And I did see on the scope, we have some stickers that say calibration void. If this or internal seals are broken, they say Simco. So I don't know if that's a third-party company that recalibrated this scope at some point or what, but there's also a sticker on the side of the scope that you would have to rip apart in order to take the back cover off, which we're about to do. And I can see it's already been ripped off. So this scope has probably been opened before, and that's probably why the handle and the power button are missing. So let's go ahead and pull the back cover off. I almost forgot, there are clips on the bottom section of the bottom cover that we have to separate. So let's do that with a spudger. There we go. And none of the clips are broken, so that's nice to see. So now, ideally, this cover should just come right off. And yes, it does. So here is the inside of our scope. So right here we have the power supply, and then here we have the actual main board for the scope. And you can see that a little bit better when I tilt the scope up. Right here we have our 60 megahertz crystal, and this is the connector for your expansion module if you have one installed. So what we can do now is remove the front cover, and so to do that, you have to pull off all of the knobs on the front, and they just pull right out. If I go ahead and grab one, it just pulls right off. So go ahead and pull off all the knobs, and then the front cover should just pull right off. And there we go. You can see we have our button membranes right here. They just sit inside the front cover, so those are very easy to access and clean. And this is also how you would get access to removing the front feet. So once you get the front cover off, these feet just slide out. They're not glued in or pressed in or anything. They just slide right out. Super nice. And so you can see on the front of the scope, we have our contacts for each one of the buttons, as well as all our potentiometers. There's a little bit of foam between this plastic lens and the screen itself, and the foam is still very good. It is not degrading at all, so I don't have to replace that. Now, I haven't looked fully through the service manual on these yet, but our main board is here, and we can look at the bottom and see what our B and C jack connections look like. And besides the one B and C jack that is completely destroyed, I do see that on the channel 1 jack, we have a cracked solder connection on where that wire is going and on the jack itself. You can see there's a little bit of solder right on the jack. If I go ahead and move it a little bit, if I look at that really close, I can see it moving. It's no longer attached to the jack. So that's why when I move this around, it goes crazy. Looks like the second jack also has the same problem. You can see that one's even a little looser. So that'll need to be resoldered. You can see on the pads themselves, the connections are cracked as well. So that'll also have to be reflowed. The external trigger jack looks very good. So I've gone ahead and I've read the service manual. So now let's go ahead and remove the main board so that we can fix the B and C jacks. So to do that, we're going to have to take all of the cables off the board. There are 4 total. And then on the bottom side of the board, there are 2 plastic clips that you have to bend out of the way so the board can come out. So once you clear those, you should be able to push it that way a little bit because it's held in by these little supports on the plastic part of the scope. Oh wow, that second jack just fell right off. So did the first one. Okay, yeah, we got some serious problems here. Oh yeah. So here's our board. You can see the external trigger jack, nice and tight, not moving at all. All the solder joints are good, but our channels completely broken off the pads. And I'm looking at the solder joints, and this is actually really good because none of the solder pads have been destroyed. It just broke on the actual jack itself. So now I can give you a better look at this board. You can see the external trigger jack, all good, but we've cracked solder connections down here, and then the jacks themselves are just completely broken. They broke right off of where they're supposed to be soldered to. You can see what happened. It didn't break at the solder pad. It's the actual jack that broke apart. So as long as I get all of the old solder and the rest of the jack out of the holes, I can easily solder in 2 new ones. So we are in the good here. You can see they're still held in by that one connection on the back. That is literally the only thing that is holding these jacks in. Otherwise, they would fall right out. So that is what we need to do to fix this oscilloscope. And through the magic of video editing, it's about 3 weeks later. And so now I have all the parts needed to do the repairs on these scopes. The first thing being the BNC jacks. These are the exact part that are on these oscilloscope boards, and I'll put the part number up on the screen. They are available on DigiKey. And I decided that I'm also going to replace the external trigger jack because it's quite oxidized, and having 2 new jacks and 1 oxidized jack wouldn't look very good. So I'm going to give this thing 3 brand new BNC jacks. So first I'll get off the 2 broken ones. That'll be really easy because I just have to desolder 1 leg and then they'll come off. There's 1. And there's the second. And obviously I'm going to clean out the solder and the remnants of the old jacks out of the front pads there. So I'm going to clean out all of the solder that's in those holes when I install the new jacks. So now let's get out this third one. Well, that's how you do that. Now I can just go, and we pretty much have our hole. And there we go. That's all 3 of the old jacks off. Now I'm just going to use the Hacko, the desoldering iron, to clear out all those holes. There we go. What I'm doing there is I'm popping the old part of the plugs. This is one of the good ones that were stuck in the holes. So I just popped one out. And there is 1 more that still needs to be popped out. And there it is. And now, since all of the holes for the BNC jacks are clear, we can go ahead and put the new BNC jacks in their place. All right, and that is what it looks like with 3 new jacks installed. I need to clean up a little bit of the flux residue with some isopropyl alcohol. But you can see now, 3 brand new BNC jacks. There's what that looks like on the back. So now this oscilloscope should be fully reliable. But I almost forgot something. I forgot about the 2 little wires here that go between the solder joint on the back to the actual jack. So I'm going to go ahead and solder those back in real quick. And that is what that looks like on the first 2 channel joints. Well, now with the main board out of the way, now I want to fix a problem with the scope, and that this one has a dim backlight. So I decided I'm going to replace the backlight on this one. So in order to get to that, we're going to have to remove the board with the potentiometers on it because the screen is underneath that board. And it looks like there are just 2 clips here, and then the board can come out. Yep, and there we go, that board is out. And as for the screen, it looks like we have 2 clips here, and then I can pull out this way. There's one, there's the other. It looks like I can just pull that out like this. And then there's a couple cables on the other side I have to deroute. And there's also one that I have to disconnect from the power supply. There we go, and I can route that through there. And there is our screen free from the assembly. So on the screen itself, these two wires power the backlight. The backlight tube is right here, and so we have to remove the old one from the screen. And to do that, it's actually pretty easy. On the side of the screen, there are 3 clips that you have to undo, and then you can take this little plastic piece off, and then you can take the backlight tube right out. See if I can undo those clips without them breaking. And yes, I can. And so this piece comes out, and there is our backlight tube right there. You can go ahead and just pull it out. So there's a close-up of the backlight tube. You can see it's got a lot of hours on it because the ends of it are starting to turn black. And I noticed that on this scope, the display was kind of warm in appearance, and they should be nice and cool white. So this backlight tube needs to get replaced. And thankfully, the backlight replacement process couldn't be any simpler. You just have to slide off these little rubber pieces. They just cover where the solder points are. So you go ahead and pull these back, and you can see right there, the wire is soldered right onto the end of the backlight tube. So all we have to do is just pull the rubber bits off until we can get to those, and then just take a soldering iron, put it up to it, and remove the wires. Super simple. 1 wire, 2 wire. So now we can go ahead and get our new backlight tube. All right, so here we have our new backlight tube, but the leads on it are a little bit too long, so I'm gonna go ahead and cut them a little shorter. And so now all it is just soldering the 2 wires to the ends of the tube. And after that, we'll put the little rubber pieces back over the top of the solder. And there we go. Now we'll have a nice, bright, brand new backlight on our TDS210 oscilloscope. And so now all we do is just put the backlight tube back in its spot. Make sure that everything lines up nice and good. And as you can see, it does. Put the little rubber parts back over the solder joints. And so now it's ready to be put back together and fully tested. But before we do that though, we need to clean up this front cover. It is filthy. Sticker residue and dirt everywhere. So let's go ahead and clean this up. And that looks 1,000 times better. All the sticker residue's been cleaned off. I gave it a very light magic erasing to get most of the scuffs off. So it looks very nice now. I also went ahead and cleaned up all of the other parts, and I will show you what those look like when we get the scope back together. Right, it's back together and it's looking really nice. So let's go ahead and test it again, and then we'll get to printing some new knobs and a new power button. All right, let's go ahead and push the power button, see if it still works. Yep, it does. I can see the backlight looks a lot better. It's going to take some time to warm up, but it's not warm like it was before. It looks really good. And with the probe plugged into the probe compensation jack, you can see we have a nice solid 5-volt square wave. And now if you move this around, you can see it is nice and solid. So channel 1 is working. And now we have a functional channel 2 because we replaced the broken jack. And if I switch over to channel 2 and then auto set it, you can see we have a functional channel 2 as well. And if you move this, nice and solid. So this oscilloscope is now fully working. We just need to add the missing knobs. And so with that, this oscilloscope is ready to be used once again. I cleaned it up and it is in very nice condition. Those new BNC jacks make it look really nice. Make it look like it just came out of the factory. New knobs, new power button, it's ready to go. I put a label on the bottom indicating the work that I did to it and when I did it, just so I remember. You can see, it just looks really nice. I did decide to remove the third-party calibration stickers because they were put on kind of sloppily. The one on the back was covering up the little hole to access the service menu button, and the one on the side was put on kind of bad, and it was ripped anyway, so I took those off. I'm going to leave all of the original Tektronix stickers on it. So it looks really nice. It's ready to be used as test equipment once again. So now let's go ahead and repair the TDS220. All right, and here's the 220. You can see it's in very similar condition to the 210, just a little dirty on the front, just like the other one, but we'll go ahead and get it cleaned up and looking just as nice as the 210. So for this one, I decided I'm not going to replace the backlight on it because it is still very bright and very cool white. So we just need to do the BNC jack replacement, which should be very easy. And on this scope, since we have the original power button and handle, we have to remove those this time. The power button cover is tall enough where you can just grip it with your fingers and pull it and it just comes right out. But as for the handle, I want to be very careful here because I don't want to break it. So the way to do it is you stick a spudger in here or something plastic. I would advise not using metal because it'll scratch up the plastic on the scope. But you just need to pry one side out just far enough so that it will pull out like that. So that's one side. And then do it to the other side. Well, that's one way to do it. So now we have both sides out, so we can kind of pry just a little bit on each side and then pull it out. And there you go. Handle removed, nothing broken. And from this point on, it's just like the other scope. And fingers crossed that none of the clips on the bottom side are broken. There we go, finally. Holy crap. I don't think the scope has been opened before because that was a lot harder to get out than the other one. Hey, you know what? I think someone has been in here because the two little clips that hold the main board in are broken. So someone's definitely been in here before. But just taking a look around, I don't see anything that needs attention. Like I don't see any leaky capacitors on the power supply. I didn't see any in the other scope either. They all look to be very nice. So let's go ahead and keep taking this thing apart and see what it looks like. The inside of there looks nice. The inside of this looks nice, and the membrane is in good condition, just needs to be cleaned. And I can see on the main board of this scope that we have cracked solder connections on the first jack, but not on the second or the external trigger jacks. And that makes sense because channel 1 is the only one that's loose. Channel 2 and the external trigger are fine. But I still am going to replace all 3 of the jacks just so that it looks just as nice as the 210. And on this one, the main board should be real easy to pull out since those clips are broken. Yep, there we go. And yep, we have the same problem that we did on the other scope. The channel 1 jack has broken off in the same way. It didn't break the solder pads. The actual jack just broke. And channel 2 and the external trigger jack are perfect, so these will be added to my spare parts. This board has a little bit of a bend in it, probably just because of those broken clips, but it is working, so I'm not going to worry about that too much, but that is something that I'll have to keep an eye on. What I'll go ahead and do, just so I can clean up the inside of the scope real well, is just remove all the other components, just so I can see how they look, and then that'll leave me with a blank slate to clean this up. It looks pretty clean in there. And I didn't do it on the other scope. Let's go ahead and remove the power supply and see what that looks like underneath. Yep, looks very nice. I don't see any work that has been done to this power supply. So now that'll let me clean up this plastic piece real easily since everything is removed. And just for the heck of it, let's take a look at the condition of the backlight that's in here. I can see it's been used a little bit. There's a little bit of discoloration on the edge there, but it's in much better shape than the other backlight. I'm just going to leave this in it until I think it's ready for a replacement. Well, you know the drill. Let's go ahead and replace these 3 BNC jacks, clean up the scope, and make it a nice, reliable piece of test equipment again. There is our TDS220. You can see it came out looking really nice. I was able to clean most of the marks up on the front cover. I have some new 3D printed knobs installed, new BNC jacks that look really nice. And here's what the rest of it looks like. Cleaned up very well. So let's go ahead and test it. All right, the TDS220 is now plugged in. Let's push the power button and see if we have a working scope now. Is it actually plugged in? Yes. What? Well, I found the problem, and it is a common problem with these oscilloscopes when they age. So I did a little bit of reading on these Tektronix TDS200 series oscilloscopes, and the best way to figure out if the main board is still getting power and it's still passing its power on self-test is you turn it on, and when you have the black screen, hook up a probe to the probe compensation jack, and you should get a 5-volt square wave 1 kilohertz signal like we were seeing before, and I was still getting that even though the screen wasn't doing anything. So we know that the main board is working fine, and because of that we know that the power supply is working fine because it is outputting power from this cable to power up the main board. So we know our problem is not with the power supply or the main board. The oscilloscope itself is still functional. So I turned my attention to the display. So as we saw before, the only thing that was getting power was the display backlight. There was nothing happening on the screen itself. So what I wanted to look at was the ribbon cable that goes from the display to the main board. So what I did was I took out the display and I measured continuity from the end of the ribbon cable here to the end that was in the display, and I did that on every pin, and every pin had continuity. So we know the problem is not with the ribbon cable. So then I turned my attention to the connector here. And so I was looking inside the connector with my microscope there, and I found at least 3 pins in there. You're not going to be able to see it, but at least 3 pins inside that connector are completely broken, and a lot more of them are crazy oxidized, and the inside of that connector looks terrible. And apparently that's a common problem where the lubricant that Tektronix put inside these connectors, it gets really hard as time goes on, and it basically welds the cable to the contacts in the connector. And when I was first removing that cable, it took extreme strength for me to be able to pull that out. So obviously that's what's happened here. And so the problem is entirely with this connector. But fortunately, I was able to find a 12-pin flat flex type cable connector, just like that one. And it is the same pin spacing as the original cable. You can see the 12 pins on that cable there. And it should be compatible. I should be able to desolder that connector, which is going to require me removing this bottom shield here. There's several connections holding that on. so I can get to the connector pins, and then I can remove that connector and solder in a new one. So that'll probably be here in a few days, and so I'll come back once that connector arrives. All right, so here's our new connector. It is a 12-pin, 1.25 millimeter spacing flat flex cable connector, and I test fit the display ribbon cable in this connector, and it fit in and locked perfectly. So this will be a compatible connector for the scope. I checked the pin locations on the bottom of the connector to see if they matched what was on the scope, and they do. So if you're looking to replace this connector for the display on your TDS200 series oscilloscope, you can find them on DigiKey. The part number is A100331-ND, and it is made by AMP, which is the same company that makes the BNC jacks for these scopes. So the connector will fit perfectly. So to actually remove this old connector, what I'm going to have to do is remove this bottom shield here, and there are several points that connect it to the other side of the board that I'm going to have to desolder. So we'll go ahead and get that off. We'll desolder the original connector and put the new one in its place. This is my fume extractor. Works well. And there we go. There is that bottom shield removed. And so now we can see the connectors for the display pins right here. So now I'll go ahead and desolder those, and then the connector should just fall right out. And there's the old connector right there. So the new one is going to go right there. There we go, it clicked right into place. It looks just like it was the original connector. You wouldn't know unless someone told you that it was replaced. And the pins go in exactly the right spot. So now all I have to do is just solder it back in, put the metal shield on, and we'll be good to test. So when you're soldering something like this, because this is a double-sided board, you can see there are components and traces on both sides. Whenever you solder one of these pads, you want to hold the iron on it for a few seconds just to ensure that the solder will flow through to the other side, because there are traces for the connector here on this side. And you can kind of look under the connector when you're done just to see if it has solder on them. So just make sure you do that so that you have a nice, reliable connection on the connector. And the bottom shield is now back on, so I'm going to go ahead and just clean this board up a little bit, and then we can go ahead and put it back into the oscilloscope and see if it works this time. And when I go ahead and put that display cable in the new connector here, fits like a glove. It is perfect. I can feel the cable contacts lock onto the cable, so it should work just fine. All right, so the scope is assembled enough to test. Let's go ahead and push the power button. I have it plugged in, and we'll see if it works this time. Look at that. Our display is back. The scope has started up. The contrast is really weird. It changed for some reason. You can't see it, but I can, and it is readable. I'm going to go ahead and restart it. That's weird. It starts up perfect, but then the contrast goes weird. And I'm moving the display cable around, and it does not change anything. Well, that wasn't too big of an issue to solve. It was just because the contrast in the software was set all the way up, so it was making it so you could barely read it. So you can see our display is back, and the scope is working. I'm going to go ahead and reassemble the rest of the scope, and we'll take a look at it in its final form. And there it is. The Tektronix TDS220 is now back together, fully operational. So let's do our probe test. So I'll go ahead and hook this up to the probe compensation jack. And you can see we get our square wave. I'll auto set it. And if I wiggle the jack, nothing changes when I do that. Nice and solid. And if we switch over to channel 2, turn channel 1 off and put it on 2, you can see there it is. We'll go ahead and auto set it. You can see we get a nice square wave out of there as well, and if we wiggle it, nothing happens. So this oscilloscope is now fully working. And if you wanted to do a little deeper testing on these scopes, instead of using its own probe compensation jack, you could hook the probe up to a signal generator. That way you can choose what kind of signal or wave you want to output, and then see if the scope can output it and if it's calibrated. But if the scope is able to properly display a signal from its probe comp jack, then it will absolutely display a signal from a signal generator or a device that you're testing. So both the TDS210 and the TDS220 are now fully operational oscilloscopes. But there's still one more thing that we have to do as part of this repair. For $20 on eBay, there was a listing for 2 handles, 2 complete sets of original knobs and feet for the TDS200 series oscilloscopes, which means I can have all original knobs on both the 210 and the 220 and replace the missing handle on the 210. This project could not have gone any better. And this also gives me the chance to replace some of the knobs on here that are cracked. Like this one's got a big crack in the top here. So I can just replace it with one that's not cracked. And so with that, the TDS210 is complete. And on the 220, these 3 knobs were 3D prints that I made, and these 2 are cracked. So let's go ahead and put new knobs on this one too. And with that, the TDS220 is now complete as well. And so with all of those knobs replaced and the handle put back on the 210, we are done. And so that has been the repair and restoration of these 2 Tektronix oscilloscopes from the late 90s. I'm glad I was able to bring both of these scopes back from just parts machines to fully complete, cleaned up, and reliable test equipment, and they will be a big help to me when I repair other things on this channel. So thank you for watching, and I will see you in my next video.